This video we're taking a look at the final proof that you have to be able to reproduce in the exam, and that is tan of A plus B, and this is the final one, as I said, in the trig identities sets of proofs. To prove this, you're going to rely on two other things that you have come across already or should have come across in your studies already, which is cos of A plus B and sine of A plus B. Why am I going to rely on those, or how do they come into it at all? Well, the first thing you need to note is that tan itself is actually a composition of the other two trig functions together. So tan is actually sine A over cos of A. Therefore, if I have tan of A plus B, what you will know about tan of A plus B based on above is that it's the same as sine of A plus B all over cos of A plus B. And the rest now you can take from your log tables. You don't need to prove them from scratch. You go to your log tables and you look up, what do we know about sine of A plus B? Well, in the log tables we know that it says that sine of A plus B is sine of A cos of B plus cos of A sine of B. On the bottom I'm going to change out that cos of A plus B, and that's going to be swapped out for cos of A cos B plus, or rather minus for this one, minus sine of A sine of B. Now in the exam, the way that they ask it, you will already know what your end goal is here. So my end goal is to start getting out tans from these sines and causes. So then you need to think, well, what is the connection between tan and the sines and the causes? This is our connection. So what I need to do is start dividing by cos of A and cos of B, because if I can do that, then I'll have sine divided by cos, which results in tan. So what I'm going to do between this step and the next is I'm going to divide everything by, let's start with cos of A, and I mean everything. So the function here, every single piece of it getting divided by cos of A. So sine of A cos of B, that is one term. I'm dividing it by cos of A. Plus cos of A sine of B, dividing that term by cos of A. All over the bottom, which is going to be cos of A cos of B, that is one term again, dividing all of that by cos of A, minus sine of A sine of B, that's one term, divide all of that by cos of A. When I do that then, working through it and seeing what I can change things into or what can drop out, sine divided by cos, those two I know will give me tan. So I'm going to change that to tan in a moment. The next thing over here, cos of A multiplied by sine of B, then divided by cos of A, well, that's doing and undoing. So it's gone. Same thing down the bottom, doing and undoing. And here I've got sine of A multiplied by sine of B divided by cos of A. Well, whenever I see sine of A divided by cos of A, I know that that can be exchanged out for tan. So let's tidy that out. What I'm left with then is tan of A multiplied by cos of B. Nothing happened with that, so it's just cos of B, plus sine of B all over cos B minus tan A by sine of B. The next step then, I want to get more of the tans out. If I take a look, I've just got my tan A's out in the right position. If I take a look, there they are. The next thing I need out is a tan B. So how do I get a tan B out? I do the same thing as I did last time to get tan A's out. But if I want tan B's, I need to divide by cos B. So dividing everything through by cos B, then I'm going to have tan of A times cos of B divided by cos B plus sine of b divided by cos of b. And again, I have to divide every term through, and the reason why I have to do that is because it's the rule of fractions. I don't want to change the value of the fraction or the meaning of the fraction or the value of it. I need to keep that part the same. So each term in the fraction gets divided by cos of b, and so long as I do that, it still has the same value. Working through this then, again, look, I've cos b divided by cos b, that's going to drop out. Look what happens now, sine b divided by cos b. We know that sine over cos of the same angle is tan. So that'll reduce to tan, as will this. And then cos b divided by cos b, well, that leaves us with 1. Not 0, but 1. Tidying it out then, I'm going to be left with tan of a plus tan of b on the top, all over 1 minus tan of a multiplied by this, which we said reduces down to tan b. So tan a times tan b. And there we have it. If I go back up to what I was trying to prove, this is what you'd be given in the exam. It would just say prove this. That's what you're going to use. You're allowed to use the proofs that came before it. Those are in the log tables. Every piece of that is in the log tables. And when we do the algebra on it and it reduces down, we get it out.